Hello friends and welcome to my channel. So in today's video we are going to be solving an interesting calculus word problem. An open tank of square base is to be made from a square sheet of metal of size 20 meters by cutting square pieces from each of the corners, lifting the resulting flaps and soldering the edges together. Find the maximum capacity of such tank. Now, when faced with this kind of question, of course, we know that it's a word problem. So, the very first thing you should do is to interpret the question mathematically so that you know the mathematical approach you use and to also have a clearer picture of the problem you're facing. Now, let's start solving. From the question, the tank is to be made from a square sheet of metal with a side length of 20 meters, and square pieces are to be cut from the corners of this square sheet of metal. Now, what do we know about squares? Of course, we know that all sides are equal, which means that the square pieces would have equal side length. That's the square pieces we are going to cut from this square sheet of metal will have equal side length. In this case, we don't know the side length of the square pieces, so we'll just assign an alphabet to it. We'll just go with X. Now, as you can see, when these square pieces are removed, each of the remaining flaps would have a length of 20 minus 2x because we removed a total length of 2x from the original 20-meter length of each side. Now, when these flaps are lifted like this and the edges soldered together, we get our square-based tank. The top is not closed, so you can see the inside. Also, remember that each side was made from these flaps, which means that the side length of the square would still be 20 minus 2x, and the height of the tank would be this place, which means that the tank's height would be x, as you can see. Now that we have our tank, the next thing we are supposed to do is to find the maximum capacity of the tank. The capacity of an object in mathematics talks about the volume of that object. That's the amount of stuff that will occupy the whole volume of the object. Therefore, in order to find the capacity of this tank, what we need to do in actuality is to find the volume of the tank, and volume is given by base area times height. Now, for the base area, the base of the tank is a square and the area of a square is length squared. So our length is 20 minus 2x, and squaring it gives 20 minus 2x quantity squared, and we have our height as x. So now, putting all of these back into the equation for the volume of the tank, we get V is equal to 20 minus 2x quantity squared times x. Now, 20 minus 2x quantity squared will simplify to 400 minus 80x plus 4x squared. We put back our x. Now, when x multiplies everything in the bracket, we get 400x minus 80x squared plus 4x cubed, which gives us the equation of the volume with respect to x. Now, since x is the only variable here, it means that the value of the volume can only be determined by the value of x. Remember that the question demanded that we find the maximum volume of the tank. So in reality, when looking at this equation, the question that should pop up in our mind, that the question we should be asking ourselves is, what is the value of x that will give us the maximum value of v? This is the question we should be asking ourselves when looking at this equation. And this question actually makes sense because when you plot this equation on a graph, you find out that the curve would reach a maximum value. I know that the question that might pop up in your mind at this stage might be, do I need to plot the graph to be sure that the equation would have a maximum point? And the answer is no, because you can simply solve it to know your answer. Now, the graph I showed you, as you can see that at the maximum and minimum points, the gradient of the graph is always 0. So in order to find the maximum volume, what we need to do is to find the gradient of the volume, that's dv over dx, and equate it to 0. Now, differentiating with respect to x, we have dv over dx is equal to 400 minus 160x plus 12x squared is equal to 0, because we're actually looking for the value of the gradient when it's equal to 0. Now, let's concentrate on this part. All of the terms in this equation is divisible by 4, right? So we get 4 factored out. We have 100 minus 40x plus 3x squared is equal to 0. Now, dividing both sides by 4 gives 100 minus 40x plus 3x squared is equal to 0. Rearranging the left hand side, we get 3x squared minus 40x plus 100 is equal to 0, which simplifies to 3x squared minus 10x minus 30x plus 100 is equal to 0. Now we can group and factor out common terms. We can factor out x here to give 3x minus 10, and 10 here to give 3x minus 10. Each of these terms have 3x minus 10 in them, so we can just factor 3x minus 10 out to give x minus 10. Now, for this equation to indeed be equal to 0, then it's either 3x minus 10 is equal to 0, or x minus 10 is equal to 0. Solving 3x minus 10 is equal to 0, we get 3x is equal to 10, and hence x is equal to 10 over 3. Solving x minus 10 is equal to 0 gives us x is equal to 10. Now, since we have two values of x, we have to, of course, find which one gives the maximum value of v. We can, of course, do this by using calculus, but the fastest way would be to substitute these values of x directly into the equation for v, then choose the highest value of v we get. Now, let's just go with x is equal to 10 first. Now, substituting x is equal to 10 directly into the equation, we have 20 minus 2 times 10 quantity squared all times 10, which gives 20 minus 20 quantity squared times 10, which is 0 times 10, which of course gives us 0. So when x is equal to 10, v is equal to 0. Now, let's take x is equal to 10 over 3. We have 20 minus 2 times 10 over 3 quantity squared times 10 over 3. I'm going to use the calculator for this one. So when x is equal to 10 over 3, we have that our volume is 592.592. Oh, and remember to put down your units, which in our case is meter cubed. So the maximum volume of the tank is 592.592 meter cubed. And that brings us to the end of the video. Please don't forget to subscribe to my channel and like the video so it gets recommended to others who might find the video helpful. Thanks for watching, and see you again in another interesting maths video. Have a nice day.